what I'd like to do now is introduce you to our presenter, who I've worked with for the last 10 years, and I'm really excited to hear her again today. Dr. Martha Burns is an adjunct associate professor at Northwestern University and has authored 3 books and over 100 journal articles on the neuroscience of language and communication. Dr. Burns' expertise is in all areas related to the neuroscience of learning, such as language and reading in the brain, the bilingual brain, the language to literacy continuum, and the adolescent brain. Dr. Martha Burns is a fellow of the American Speech Language Hearing Association and the director of Neuroscience Education for Scientific Learning Corporation. Please help me welcome Dr. Burns.
Well, thank you so much, Rhonda, and welcome everyone. I'm delighted to see everyone. There's a ton of research to go through with you. It's just exploding right now, the research. So I'm going to get started right away and get into the talk, so we'll have plenty of time for questions at the end. Since this is Read Your Mind, I'm going to start with the reading brain and the research on the reading brain. As you can see, this particular article was published in the International Journal of Behavioral Disorders in 2018. And what you can see is the major areas that have been identified as being part of what we call the reading network. And they include what most of you, I'm sure, are well aware of, the language network, which is the left superior temporal gyrus, very important for perceiving speech sounds and being able to break sounds down into their component parts. The left supramarginal gyrus, which is a symbolic center, enables you to link one modality to the other. So in the case of reading, we're linking vision to sound, but there are other ways that the left supramarginal gyrus operates in symbolic skills with other senses. The left inferior temporal region that you see down there is kind of embedded right next to what we call the visual word form area. And it's going to be, B is going to link A and C together so that children can decode. So those are the primary decoding centers, if you will, all operating together. Then we have at the bottom D, which is the left parahippocampus, which is very important for retaining information. So it's very important for holding on to recognition of words, being able to recognize them and go directly to meaning. In the beginning, it'll be very important for sound letter retention. And then finally, the left or the right calcarine fissure is E, and that is the visual association cortex and the primary visual cortex, very important, obviously, for the input of the grapheme itself. And in this particular research that was done, as you can see, done last year, what they did is they looked at each of these components of reading: phonological representation, phonological awareness, phoneme to grapheme mapping, morphological awareness, the ability to understand and utilize word endings and affixes, prefixes, as well as words themselves, and then also the orthographic semantic mapping, the ability to go directly from word to meaning. And that's those A, B, C, D, E areas again for you, and just showing you in this case how they are linked to that particular capacity. And those are, of course, the primary capacities that we think of in terms of the skill of reading. But in addition to those regions of the cortex, because it's a network, they have to be connected together. And the way that they're connected together, as you all know, is through long fiber tracts. And there are some major fiber tracts that are very important for reading. We're going to go through these several times today that interconnect these regions, but a big one is this, what's called the arcuate fasciculus, and you can see it in this diagram. It's a little hard to see if you're looking at it and it's real small, but it's the red one that says left arcuate fasciculus, and that is the fasciculus that's so important for the whole language network. And what you're going to see in a few minutes, and I just got a new article today out of Nadine Gaab's lab, at Boston and Harvard, showing that when that particular fasciculus is not as thick when children are born, if they follow the children longitudinally to kindergarten, those children are more likely to have difficulty with language. So it is a very important language network, but we also have some what are called longitudinal fasciculi. The blue one that you see runs from the occipital lobe all the way through the temporal lobe to the frontal lobe, and so it's called the occipital frontal longitudinal fasciculus, and it's very important in reading because it's going to enable the child to obviously link vision and the symbol systems to the auditory signal through the temporal lobe, and then utilize it as it gets to the frontal lobe. So these are then the components that we know are associated with reading. They show up in many different ways. We'll talk about it more later. But let's look at the classical view of reading. The classical view of reading, or sometimes called the simple view of reading, SVR, is that skilled reading essentially has two major components. One is the word recognition component, the ability to decode, to map sounds to letters, phoneme, grapheme mapping, and then the phonological awareness skill, the ability to parse words into sounds. And then the language comprehension component of the skilled reading view is that a child also has a wealth of vocabulary and meaning associated with the vocabulary, and of course grammatical understanding, specifically morphological endings, morphological affixes, prefixes, etc. So it is a combination of language skills and word recognition that in the simple view make up language, and it's a comfortable view because it is easy to understand, and it includes all of the components that are often included in an educational program. But what we know now, because of the years of neuroscience research, is that the SVR components are not single entities. They're multifactorial, they change with time, they change with experience, and they're context dependent. And we know that from Katz's research and some wonderful studies of Katz. Then we also know the research indicates that skilled reading is dependent on oral language skills, but also knowledge of academic language and reasoning. And we're going to spend more time with that. Snow et al. Did a nice paper on that. And then additional cognitive skills that are important. And I'm going to spend quite a bit of time with you on that. Students have to be able to pay attention and maintain their attention. They have to be able to hold on to information, both phonological information for phonological working memory, and then also other types of retention skills that we'll talk about. So the newer research is really focusing, and this was a paper by Delcourt that just came out last year et al., on the role of executive functions, these cognitive functions, that suggests that we have a set of regulatory processes. They're basically the prefrontal lobe capacities. They're important to reading achievement, and they're very important when we talk about moving from learning to read, where children learn to decode and they learn to attach meaning to both graphemes and combinations, but also the capacity to read to learn, which of course has to start taking place around the 3rd to 4th grade so that students can achieve in school. And it is that element of the cognitive components that has become a huge area of research over the last few years. Just as a review, executive functions include response inhibition, the ability to pay attention to a specific stimulus and ignore other kinds of stimuli that are impinging on you. Right now you might be listening to me, but you might have other things going on, and you're trying to focus on this auditory signal and ignore the others. But it's not just ignoring, it's also keeping yourself from moving around and getting up and jumping. And all of us who've worked with children know that response inhibition, it has both a doing side and a receptive side. Children have to inhibit their responses that are inappropriate as well. It also includes executive functions, include updating and monitoring of what's going on. So you're listening to me, you're comparing what I'm saying now to what I said 5 minutes ago. You're comparing it to what you've read recently and what other people may have been talking about. And all of that is this updating of your RAM, if you want to say it that way. I think of working memory as the RAM of our brains, where we're just constantly changing and updating information. And then the third component of executive function is flexibility, being able to shift from answering a question one way or reading a sentence one way to thinking about it another way, and applying knowledge. And so in that model, then, we have really three components: flexibility, attention, and working memory. And then added to that, executive functions also include reasoning and problem solving in many of the models that are out there. Now, we also know that they're very important. Attention and memory and other executive function cognitive skills are important also for language comprehension. There was a wonderful paper published by Montgomery and Gillum in the Journal of the American Speech Language Hearing Association a couple of years ago on the importance of looking at cognitive skills in addition to linguistic skills. So if we have an updated view then of this simple view of reading, the SVR. It's a little complicated slide, but we're going from skilled reading to thinking about academic success. So we're putting everything into the same envelope, if you will. Academic success depending on the ability to read to learn as opposed to learn to read. And so what we have is phonological awareness and decoding, with the current research adding the importance of phonological representation. You saw that in the slide at the beginning. Phonological awareness, of course, and then phoneme to grapheme mapping. We have on the right language comprehension, with the current research adding to the morphological awareness, also the orthographic semantic mapping, the ability to go directly from a word to meaning. And then finally, we have the cognitive and executive function skills that are impinging on this: the ability to hold information in mind, the ability to attend and focus and ignore stimuli that are interfering, and then cognitive flexibility and reading. And when all of that is intact, then the student excels academically. So you came here today because you wanted to know more about dyslexia, and we'll start with reading impairments. And the reason that I'm going to start with reading impairments as opposed to dyslexia is that there's quite a bit of discussion among a lot of reading specialists around the world as to whether dyslexia is an entity in and of itself, or whether we have a broad umbrella of different reading issues. And some of them may be described as dyslexia, some may not. And this is a current debate that's going on, and I would say that it isn't answered. Some people have very strong opinions about it, but what I'm going to do is address it from both perspectives, because both perspectives have some merit, and we'll talk about that. So we'll start with the idea of reading impairments. For many children with reading impairments, the process of learning to read is rife with struggle and frustration, and these children are less susceptible to adverse secondary outcomes, and those can include anxiety, those can include depression. And this comes from a wonderful recent paper by Nadine Gaab. And so what we want to think of then is, okay, let's think of reading impairments first, because that's where we want to understand what are all the mechanisms that go into a reading difficulty, but then we also want to obviously know what do we do about it. And that's where I want to take you today in the research there. Dyslexia as a term, I want to provide the historical perspective, because those who don't care for using the term dyslexia or feel that it limits the way we view it, it's good to understand where it came from. It's actually a Greek term that combines dys, which means bad or difficult or abnormal, with lexis, which means word. So dyslexia just means Words are hard, if you will. And dyslexia was a term that was adopted from adult neurological disorders. So years ago, alexia was identified as a component of aphasia in adults who had focal lesions to the left hemisphere. And so that term in a time, and this is really in the 60s when we were using the medical model to think about reading and other kinds of language skills. So the term dyslexia was used, or developmental dyslexia, to describe they considered a lesser impairment of reading that we would see in children. And for many years, really from about the 1970s all the way through the last few years, and in some school districts you may even still use this criteria, the diagnostic criteria for educators was what was called the discrepancy criteria. So the discrepancy criteria was a label. It could be reading impairment. Some school districts don't even use the term dyslexia or dyslexia, but it was defined as a discrepancy between a child's potential, intellectual potential, and their reading achievement. And if that discrepancy was a couple of standard deviations, then it was considered that they had a reading impairment and or dyslexia. And so you can tell right away when you have that kind of a discrepancy criteria, what you have is a broad envelope that's going to include children whose reading may be difficult for lots of reasons. It may be difficult for them because of environmental differences, socioeconomic differences, never being exposed to written words perhaps in the home, or coming from a home where there's a lot of stress where the brain just isn't developing as well. And so if we go to the more the medical definition that's used and the psychological definition really in the DSM-5, that's the Diagnostic Statistical Manual for diagnosing disabilities, if you will, of different kinds that are used by insurance companies and other agencies. Dyslexia is a clinical term, and it falls under the umbrella of specific learning disorder. And I want to emphasize this because we're going to be revisiting this when you see the research on dyslexia in a few minutes. But specific learning disorders impede the ability to learn using specific academic skills. So you can have a specific learning disorder that would affect your ability to learn mathematics. You could have a specific learning disability that would affect your ability to read. I often joke, I'm married to a man who was a professional athlete, and I've often said if they had a criteria for it, I would have a learning disability for motor skills because I'm very awkward, and unfortunately my kids inherited my motor skills, not his. But we didn't define disabilities that way. We didn't have a discrepancy criteria for kids who were having trouble with physical education. So a general learning disability then is an umbrella term, and dyslexia would be one kind of learning disability under the DSM-4 manual, or 5 manual. And then you have the educational definition, and I actually took this from a new book by Fletcher Lyons et al., which is word-level reading difficulty characterized by a core deficit in phonological processing, which is the ability to recognize and manipulate speech sounds, that impairs word recognition, impairs spelling, and impairs decoding. Now, we're going to see that although that is the definition that's widely used educationally, that definition is becoming broader as we look at the neurological components or the brain components of dyslexia, which I'll get to in a minute. And what's important is, and this is from a paper that just came out of Nadine Gaab's lab by Sanfilippo in press, reintroducing dyslexia, early identification and implications for pediatric practice. But the problems associated with dyslexia, and this is what we all care about, is reading fluency, reading comprehension, reduced vocabulary, lower content knowledge, and a decline in overall school performance. And if we think about it that way, then it helps us to realize that this is a very broad-based problem that isn't going to have a simple one-size-fits-all solution. Which takes us to what is now viewed as the multi-deficit approach to dyslexia. We have the simple view of reading, but when we get into dyslexia, all of the research that's accumulating tells us that really there are lots of components that contribute to what we call reading impairments. And you can call it dyslexia, you can call it reading impairments. It's not an issue what term you use from my perspective, but the important thing is that we have over on the right, that blue circle, we have set perceptual and cognitive capacities that we know are affected when children have trouble learning to read. Those include the auditory perceptual capacities. They also include visual perceptual capacities. They also include working memory, attention, and other executive function skills. Then the green circle at the bottom is brain level differences, and that's why you're here, and I'm going to share with you all the new research in that. But what you will see is how complex reading problems are. Reading difficulties are very complex. Dyslexia is very complex. It isn't just one kind of a problem. Over on the left, you see the interplay of genetics, and I'm going to add a word called epigenetics to this. You are born with a set of genes, we all are, that predispose us to be good at some things and not so good at others. And as I mentioned, my own children, I think, got my genes for motor skills. But then there are epigenetic effects that the environment has on your genome. And to give you an example of epigenetic effects that you probably all know, if you had a parent who had lung cancer, what you wouldn't do is smoke. Not because you have a gene that causes lung cancer, but a gene that somehow that is turned on when you smoke, an oncogene they call it, and that turning on is called an epigenetic effect. So all of us can have genes that are overridden by the environment that changes the gene in one way or the other. And that can be a factor as well. And then finally, we have environmental factors. We know that children who come from low SES homes of poverty are more likely to have reading problems. We know that children who come from homes where there's a great deal of stress or adversity in the home are more likely to have reading problems. So we also know that there are best practices for education that affect how children learn to read. And these four all act together. You can't separate out one and say, well, this is the cause of dyslexia. You can say that, yes, these all contribute, and that's what I want to share with you in terms of these four. So we have genetic factors, which I've talked about, brain level differences, the perceptual and cognitive level differences, and then finally the environmental factors. And when we get into genetics, we know that dyslexia is strongly heritable. We know that approximately 50% of children who have a sister, brother, mother, or father, someone in their immediate family with dyslexia, will receive a diagnosis themselves, and it's even higher. It's 2/3 of children who are identical twins. And that research is strong, and I've listed at the bottom, just it's a little smaller there, some of the risk genes that have been identified. It doesn't mean that if you have one of those genes, you definitely will end up with dyslexia, because there are other issues involved, the other issues we've talked about. But it does mean that it increases your risk, just like having a parent who had lung cancer increases the risk of your chance of getting lung cancer too. But that doesn't mean you'll get it, and it means you can do things to prevent it. And that's really where we go in the therapeutic world. Now let's look at the brain level differences. That's really what we want to talk about here. There's a wonderful resource for you that came out in August of 2016 on the neuroscience of education. in the journal Behavioral Sciences that I listed for you there, that is a whole journal on dyslexia and other reading problems. But I'm going to catch you up even with some more current research, some brain level research. This is actually taken from a paper by DeMello and Gabrielli that was published in the journal Language, Speech, and Hearing Services in the School last year. And what they show is that we have these three language areas that I've already described, that I will describe again, that are often associated with problems with reading. We see differences in the fiber tracts. We see differences in these regions lighting up on imaging. One is in the frontal lobe. Those of you who are speech pathologists know it as Broca's area. It's the inferior frontal gyrus. Very important for speech, very important for verbal sequencing, grammar, very important for oral use of language in general. You have this the supramarginal gyrus, this region we talked about earlier, that's the symbol center, that's the blue circle that you see, and then we have the visual word form area. And those areas are linked together, as I said earlier, and I will remind you again, by a fiber tract called the arcuate fasciculus, and that's a huge fiber tract that enables those regions to develop synchronously and to function synchronously when we read. Now, there's also research on what we call cortical folding, and as the brain gets, as the cortex and the underlying white matter of the brain gets thicker and thicker and thicker, because we have a skull that encapsulates our brain, the brain starts to fold in on itself. There are wrinkles, and the wrinkles form because you have more surface area, and the more surface area you have, if your head can't just get bigger and bigger, it increases with these folds. And we know that there are folds in the frontal lobe and folds in the temporal lobe that are structurally different. They are not as mature, they aren't as thick in students who struggle with reading or are diagnosed with dyslexia. And then these fiber tracts. And the fiber tracts are seen through what's called tractography, and that is diffusion, MRI, and that what that does is diffusion allows you to look at the diffusion of water actually in the fiber tracts, in the myelin that wraps around each of the axons. And the myelin, as it gets thicker and thicker, has greater diffusion. You can look at how the water is diffused, what direction. But it's a measure of maturity, if you will, and sophistication of these fiber tracts. And there are three major fiber tracts that we see are not as well myelinated in children, or we see differences in what's called fractional anisotropy, so the diffusion measures are different in children who have a diagnosis of dyslexia. And those include the superior longitudinal fasciculus, which is the purple one, the arcuate fasciculus, which I was explaining earlier, which is that big turquoise one, kind of overlaps with the superior longitudinal fasciculus, and then the longitudinal fasciculus that links the occipital lobe to the temporal lobe, which you would imagine that would be important too, because of the importance of the visual component of reading. Now, new research has shown, and this was just published by Langer et al. In 2017, that the left arcuate fasciculus in infants is not as well developed. You don't have as much of the fractional anisotropy, it's called FA, in children who have siblings who have dyslexia, or what you see there on the slide. It says Family History of Dyslexia Plus. That's FHD Plus, and you can see it is thinner. It just isn't as thick. And new research I just got in my mailbox this morning out of Nadine Gaab's lab, showing that they have followed children now who are born who have an arcuate fasciculus that is not as well developed when they're born, and they followed them through kindergarten, and those children, they followed them longitudinally, and those children are are more likely to have language problems and reading problems. So we know now from a longitudinal standpoint that that's a fiber tract a baby is born with that's different, and that predisposes them, puts them at risk for language problems. We also, this is some research, and I'm going to spend a little more time with this as well. This just came out this year, neurotypicals and dyslexics again, and what you're looking at is a relay fiber tract that goes from the thalamus, and it's called the medial geniculate body, that's what MGB stands for, the thalamus, that runs to the auditory cortex where you perceive sounds. When you hear anything, the gateway, if you will, to every part of your cortex, your sensory cortex, is the thalamus. And so the thalamus distributes the signal, if you will. And what you can see is that the fiber tract is thinner. In dyslexics, it is not as well developed. And that corresponds to a problem, this particular relay, a problem perceiving and handling rapid changing auditory information. And so we again know that dyslexics have an underlying difference in the way their brain handles certain kinds of information from a young age that predisposes their ability to read. Now, at the perceptual and cognitive level, what we have, this is relatively new research too, that children who are diagnosed with dyslexia don't have the capacity to their brain doesn't adapt as quickly to stimuli that come in. And I want to explain these two studies. The first study was Gabrielli's team that came out in 2016, and then there was the Ashir's team at Hebrew University came out just in 2017, kind of supporting it, but they looked at the same issue in two different ways. And essentially what they're looking at is the plasticity of the brain, the ability of the brain to take in perceptual information, hold on to that perceptual information, that's called implicit memory, hold on to it so that if you hear another signal like it, you can say, oh, that's the same. And I'll just give an example of that really quickly. If a mother says, oh, look, there's your cup. Do you see your cup? See the cup? There's your cup. Go get your cup. Go on, get your cup. Parents repeat like that all the time. Well, one of the reasons they do is repetitions for a young child help the brain to sort out what are the relevant signals and how the brain is going to organize those signals into what eventually will become a phonemic perceptual capacity. And what the two teams found different ways. Gabrielli was using functional magnetic resonance. Ashir was using electrophysiological measures. But what they found is that the brain doesn't respond as quickly to repetition. The children who eventually have dyslexia ended up having much more problems making use of information, especially if they had to hold on to it longer. So they need a lot more repetitions. And the reason I'm emphasizing that is when we're talking about intervention, one of the things that we have to keep in mind is these children need a lot of repetition over and over and over and over again, and they need the sensory repetition. So they need to hear the sound, then hear the sound, then hear the sound, then hear the sound, then see the sound, then see the sound, then hear, see, over and over again to override this difficulty with plasticity. Okay, then in addition to that, we know from a cognitive standpoint and from a perceptual standpoint that there's been a lot of research for many years, over the last 15 to 20 years, on what are called the phonological deficit theory and the orthographic. And essentially, the phonological looks at phonological awareness. We've known for years that children who have trouble reading often have trouble parsing words into sounds. So if they hear the word cat, being able to say that the three sounds are cat. If they hear the word cat, being able to blend them together. If they hear the word cat, being able to say what was the first sound, what was the last sound. And that deficit is very pronounced in children with dyslexia, but we also see orthographic deficits as well, that they have trouble identifying written letter patterns and words as a whole very frequently. It isn't quite as severe usually. Usually the phonological deficit is an overriding deficit, but the brain, as complex as it is, we never want to eliminate one contributing factor to what a child might have when they present with dyslexia. And the big picture here with all this neuroscience research is that dyslexia-related differences are now seen in pre-readers. That new research I just told you about that I just got in my desk this morning out of Nadine Gaab's lab, where she showed that the arcuate fasciculus actually looks different in children right after they're born, and they follow them through kindergarten. So because we see all of these differences, these neurological differences, phonological perceptual differences in children before they even begin to read, that provides us the evidence that there are neurobiological differences in these children that precede the reading. And that reading problems are not just experience-driven. It supports the phonological theory deficit, but we also see differences in the occipital and temporal regions. We don't see them quite as consistently. This is Vandermosten, 2018, in that kind of red journal I told you about earlier. But we do see them. So we don't want to discount any of the components that could contribute to a reading problem in a child, and we don't want to try to oversimplify what dyslexia is. It is complex. There's other pre-reading research on dyslexia that shows the importance of auditory processing. Question we always want to ask as neuroscientists is, if a child has a problem with phonological awareness, what is causing that problem? And it looks like that problem is caused by auditory processing deficits. And there was a wonderful paper published in 2015 by Chrisman, Lockman, and Steinbrink in the Journal of Speech, Language, and Hearing Research on the results supporting a generalized auditory perceptual impairment in many of the children. And remember, again, the brain is complex, so not every single child will necessarily exhibit an auditory processing problem, or they might outgrow it, if you will, because of other environmental and exposure components. We want to look at the big picture. And then finally, we always want to consider spelling and orthography. English is not a transparent language. There are many alternate spellings for the same sounds. We don't have a nice, pure, transparent language like we would with Italian or with other more direct phoneme grapheme sounds. And so many children have trouble when they get to the orthographic level and the spelling level, learning all the rules and learning all of the irregularities, etc. With respect to the cognitive level differences, we'll reemphasize again, and this was just a paper that was just published that summarizes it nicely by Donnelley and Christiansen in 2018, that response inhibition, attentional problems, working memory problems, and working memory for phonemes, so holding sounds in mind, but also working memory for visual and contextual information, remembering how the words look, remembering to be able to recognize sight words that you can't decode, and visual working memory. All of those are components to reading and reading difficulties, and of course cognitive flexibility. And we know that from words where we have a single word that might have 4 or 5 different meanings, and being able to make sense out of that when somebody's reading and not get lost in a single meaning of a word. We also know it's very important to identify these children early. All of the new research is telling us that because these characteristics, the neurological differences, other kinds of cognitive differences now can be identified in very young children. Nadine Gaab and her lab at Harvard has really emphasized the importance of getting that message out to physicians, getting that message out to parents so they know what to look for and they can get their child identified as quickly as possible. because the way that we diagnose dyslexia now still is the failure to learn to read. So most of the children are diagnosed at the end of second or beginning of third grade. It's called the wait to fail approach. So the children are not given any interventions until they're starting to have a problem. And as every parent who's listening today knows, and I know with my own, I have a daughter who was diagnosed with dyslexia. And brother, when you get that diagnosis in the third grade, it just knocks you off your legs, because you have a child who seems to have been very smart, who seems to have been doing very well, and all of a sudden they're just falling apart at learning how to read, and they get a diagnosis. And if we can get to them at 3 and 4 and 5-year-olds, as 5-year-olds, and build up the cognitive skills, working memory, attention, build up the auditory processing skills, build up the brain's capacity through multiple repetitions to become more plastic to sensory stimuli, then we probably could prevent a lot of the reading failure that we have in schools. And that's really where neuroscience is going right now. There's a useful resource I want to draw your attention to. It's the National Center for Learning Disabilities. And there's a website that includes all sorts of checklists that parents can go to, teachers can go to, physicians can go to, that identifies signs that could place a child at risk for any number of different learning issues. And it's a website that's available to everybody. Now, before I go too far into intervention, I do want to emphasize that there are also individual differences, that we as humans like to have diagnostic categories, and we like to be all or nothing in our thinking, that this is the way that I should approach this problem, and this is the best way, and this is the only way. And what neuroscience is starting to really draw our attention to is that you can have 25 children with exactly the same diagnosis, and they might even exhibit some of the same behaviors when you have them try to read. But when you actually go in and work through these different components, one child might have trouble with attention, another child might have more trouble with working memory, one child might have more trouble with auditory skills, another child might have trouble with auditory and visual skills, one child might be having more trouble with contextual language and being able to hold, and other children with grammar. And so we don't want to just to look for a single solution to such a complex issue. We want to treat each child as an individual. And that's happening in cancer research, if you know that. It's called personalized medicine now, where if you have a diagnosis of cancer, you are no longer given the chemotherapy that everybody else got 10 years ago. You are looked at genetically, you're looked at from all sorts of different levels, and then they try to personalize the intervention to you. And that's where we want to go with children who have a diagnosis of reading problems. Each child is unique. They will exhibit perceptual strengths as well as weaknesses. We want to identify those strengths. We want to know what those strengths are. A wonderful professor of mine years ago, Doris Johnson in Learning Disabilities, often said, you get to the weakness through the strength. And knowing a child's strengths and being able to get them to capitalize on their strengths and understanding that they have those strengths is very helpful. Children will have cognitive strengths and weaknesses, and children will have linguistic strengths and weaknesses. And we need to think about all of that and consider that. So a successful reading approach is one that addresses and accommodates and adapts to individual brain-based differences. And that's what we want to think about. Yes, we want to focus on decoding and phonological skills, since we know the majority of students who have trouble with reading, that is a focal point. But we also want to look at their language comprehension, their vocabulary, their morphology, make sure we're building that up. We also want to address cognitive skills. If they have attentional problems, we can train that. If they have working memory issues, that can be trained. If they have problems with flexibility of thinking, that can be trained. And even more important, in adolescent readers, it's really important that we train and scaffold and enhance their skills, because once students start failing, they start thinking of themselves as being a poor student and not very, quote, smart. And when that happens, they're likely to give up. And we know that there's a lot of research. There's a wonderful paper on this by Wang et al. That just came out this year on the necessity of building executive function processes in older students, top-down approaches to help them to overcome some of the issues they have in academics. So that takes us to interventions and the role of neuroscience-based technology. So where does neuroscience take us? Well, where neuroscience takes us is it wants to enable every intervention to adapt to each individual student. Each individual student or child's ability in their phonological awareness and phonological skills, their processing skills, if you will, both auditory but also visual as well. We want to make sure the language skills are worked on and are strong, both grammar, morphology, vocabulary, and contextual language, and then these executive functions of working memory and attention. And the nice thing about technology is that you can build exercises that cross-train lots of different skills that give repetitive stimuli over and over again, so the student can just sit down and work and work and work at their own level, and those exercises will adapt. So if the student's good at phonological awareness, they'll zip through the exercises that work on phonological awareness and be able to spend more time on exercises where they may need more effort. This is just an example of an exercise like this. This is called bear bags. It's a phonological awareness task. What the bear does is he holds up a picture of something, like he might hold up the picture of something that ends in a D, like I'm trying to think of the word bad we have right there, but maybe the word bad. And then the child has to identify which of the pictures has the same last sound. What you see is in the speakers below, the student can actually click on and hear the word if they want to hear each of the ending sounds. This can train them with initial sounds. It can train them with final sounds. It can train them with vowels. And it's just a pure phonological awareness task. But what will happen is that gradually they'll hear the word and see it, then gradually they'll just have to recognize it visually. They'll have to hold it in mind, so you can get at working memory, you can get at auditory attention, you can get at phonological awareness at the same time. This, you don't really see a picture, and I can't play it for you, unfortunately. I don't think it'll turn on. But this is just oral language comprehension, where a student might learn grammatical past tense, and then present tense, and then future tense, and then auxiliary verbs. And they'll hear a sentence, and then they'll get 4 pictures in each of these squares. And they have to identify the sentence that goes with what they heard. And again, they have to hold on to the sentence, so it gets a contextual working memory, and at the same time, language comprehension, vocabulary, and morphology. Then you can work working memory, phonological working memory, and students in the Fast Forward programs that I'm illustrating here are getting 4 or 5 of these exercises every single day, so they're cross-training all of these skills. This is a phonological working memory task that's like a concentration game, where the students clicks on a speaker and they hear a word like hat, and then they click on another speaker and they might hear fat, and then they click on another speaker and they might hear cat, and then they click on another one and they hear hat again, and they have to go back and remember where they heard the other hat. And that is designed to get at what I was telling you about, that research showing that the students need to hold on to this implicit memory and to keep going and hearing the repetitions over and over again. They could get hundreds of repetitions of a task like this in one single 20-minute or 10-minute exercise. This is just working on grammatical skills. This is a reading task where the student has a closure task. It might say the boy who won the race was blank, then the boys who lost the race, and then they might have 4 choices like faster, fastest, fast, and they have to pick the right word ending, that it would be comparative in that case, and fill it in. And they might, again, get 100 of these different examples where they're working on morphology in a reading closure task and grammar. So you're getting, again, at both working memory, in this case visual working memory, as well as language comprehension. And then to train the visual skills as well as the sight vocabulary reading skills, as well as what we call response inhibition, this ability to attend, we have activities like this one where this pelican will say a word that's a sight word, and then fish will start swimming across the screen from left to right. So you're working on left to right visual tracking, and there'll be words that are could be confused with that sight word, and the child has to pay attention. They have to maintain their attention. They can't click too soon. So you're working on the attention skills. You're working on the visual tracking skills, and you're also working on sight word vocabulary. And then the student clicks on the word when the right word swims across the page, and the words will go faster and faster and faster as the student gets better and better, and there'll be more higher level sight vocabulary. So it adapts to the student as they progress. And then as students progress for flexibility, they'll have synonyms and antonyms they work on for flexibility, and homonyms. They'll also have a task like this where they'll have a sentence that is a complex sentence in this case, and then they have to find a sentence that has the same meaning, but where it's no longer in the complex sentence form. So they're paraphrasing. And that's designed to build, of course, language and reading comprehension, but flexibility as well. We know that education technology, when you combine this with good teaching, what you can do is revamp skills. So students can get all of these repetitions in a way that's personalized for them, individualized for them, in a way a computer can deliver it that a teacher can't. But then they get the value of the instruction in the classroom as well, with powerful teachers who can make it all exciting and useful and move the students along through the curriculum. And that is very powerful. We know from fMRI research, first done by Temporal and her group, and then followed up by Nadine Gaab's lab later on, that when we look at children who are reading impaired before and after training, what we see with fMRI after, in this case, just 8 weeks of the fast-forward exercises, is those regions of the brain that were not lighting up in the middle picture there, that we see light up with typically reading children, now light up. In other words, those parts of the brain are building, and the plasticity and the repetition is working for those students so that they are actually able to read. And we know with school districts around the country now, around the world, that when students use the Fast Forward products combined with Reading Assistant, this was a school district St. Mary's Parish in Louisiana, and you can see they started using Fast Forward in 2006. That school district was under the state average, which is the silver line, and you can see that as the state average improved, so did the red line, is the state average. The silver line is the state average. The red line is the Fast Forward group. But you can see that it was below the state average, and then as the students proceed through the years, and these are elementary students as well as middle school students, we see them not only keep up with the state average, but actually rise above it. And we see success in multiple subjects. The students are reading to learn, not just learning to read. And so you see the trade-off in all of the areas where language and reading are important. So that is my talk for today. You can get more slides. I think probably Rhonda will come back on and tell you where you can get more information if you want to go in, and she'll be sending you emails as well. But I will open it up to questions now.
Thank you, Dr. Burns. That was a lot of useful information. We have received quite a few questions, so I'll go ahead and start on that. The first one is a bit long. So this one is, many students diagnosed with dyslexia exhibit co-occurring cognitive issues in areas like attention, processing, and working memory. On IQ tests, such as the WISC, these may result in a low IQ score. However, some psychologists feel these should be considered separate diagnoses, while others see the combination of cognitive deficits and dyslexia as indicative of a general learning disability. What is your opinion?
Okay, and we did kind of address this, so I'll just go back and review that many children who do have a diagnosis of dyslexia, who have all of the evidence that we see of dyslexia, if we look at fMRI scans, if we look at other ways of diagnosing dyslexia, do have cognitive impairments, and that does often bring their IQ, their total IQ down, especially their performance IQ might be high, but their verbal IQ will be lower because of that. And we can call it a general learning disability, but it's probably most effective to think of it in terms of reading and cognitive skills combined, because then we can work on both of those and enable those students to achieve. And our end goal is to enable our students to read to learn. And so our end goal is achievement, and not a diagnostic category or a term from my perspective. And so understanding that cognitive issues are a part of dyslexia, I think, is important for psychologists so that they realize that these go together, that they aren't always separable and distinct. But when you improve the cognitive and reading skills, the verbal IQ will go way up, by the way. So great question.
Okay, and the next one is, do we risk missing or underestimating strengths of a student diagnosed with dyslexia if we don't extend our testing to include broader IQ measures or measures of cognitive skills?
And I would again say yes. I think the more broadly that we can assess these students, the better, because what we're learning in personalized medicine, what we're learning in personalized intervention for students or individualized intervention, is that there are a lot of individual differences, and we want to understand strengths and weaknesses so that we can focus on each student's unique capacities. We don't want to clump them together under a diagnostic term and assume that one approach is the best approach, one size fits all. We want to make sure that we're looking at the whole child. It's expensive to do that. A lot of school districts, that's difficult, but it's very important, I think, that the psychologists be brought into the team and do full diagnostic evaluations of these students so that we know their full range of strengths and weaknesses, and we can address them individually.
Okay, and the next one is reading impairment equivalent to dyslexia in terms of diagnosis, or does it imply a lesser degree of severity?
It depends on where you are. It depends on what terminology that particular area uses. Most people will consider reading impairment to be a lesser impairment or an impairment that isn't neurological. So because dyslexia came from that neurological history, the medical diagnosis history, many people reserve that term for students who have very severe reading impairments that can be tied to specific neurological capacities or neuropsychological capacities if you're a psychologist in doing that kind of testing. Reading impairment, on the other hand, could be used as a broader umbrella to include children who may not have had exposure to the written word until they got to school, so that they're behind, or that they have weak language skills, but that their reading skills might be intact once they begin to improve their language skills. But again, these are semantic differences that you'll see vary by school district, by state, by country, and by philosophical view. And my hope is that we can let go of worrying about terminology and just think about every single student that is not doing well in reading and individualize our thinking about how to handle that. Now, the only side of that I have to say is that if a child has a diagnosis of dyslexia, they can often get extra services in a school. It entitles them to extra services, whereas if they have reading impairment, it doesn't. For an IEP, also, they can get insurance coverage if they have a diagnosis of a dyslexia. Often, if it's reading impairment, they don't. So for that reason, the terms are used to enable students to get access to services. But again, I'm hoping that we can be more open-minded than that as we move in the forward and think about these children as individuals, each and every one of them.
Okay, and then which test is the best for screening a child with dyslexia?
I wouldn't say that there is a best test. Again, just based on what I've said before, I would really advocate that if a parent thinks a child is at risk for dyslexia, or if a school thinks that they are, that they have a psychologist, an educational psychologist or neuropsychologist do a broad-based assessment of the student. To screen, there are several instruments out there that are widely used, the CTOP, for example, but you don't want to miss a child, or you don't want to miss a component of what's going on when you're diagnosing something like this, because their life depends on this. If a child loses 3 years of education, if they're from first grade to third grade, if they screened out and it looks like they're all right, and no one diagnoses them until the third grade because they just had a screening test, they have had 3 years of failing in school. They have had 3 years of feeling inferior to other children. They have had 3 years of really struggling, and it's going to take another 2 years or so for them to be able to catch up, or certainly a year, depending on how intensive the intervention is. And so I would prefer that we don't screen, but that we start with screening and then go for a full assessment of every child.
Okay, another question is, when working with a student with dyslexia one-on-one, what are the top 3 strategies you would recommend a teacher use to build reading-writing skills?
The top 3 strategies, again, I'm going to opt for. Now, I'm a therapist, not a teacher, and I think teachers, when they're thinking about tutoring, are certainly using a broader brush, if you will. And certainly phonological awareness is one very broad brush, and decoding. So that's something in the Wilson programs, and there are other programs out there, Orton Gillingham, that really emphasize that. And I think that's an important strategy. But we also have other orthographic skills that need to be built, spelling and knowing spelling rules, and then we have these underlying cognitive skills. So I again hesitate to list 3 approaches that I would say would be best, because in my experience, I've never worked with 2 children that needed exactly the same kind of approaches. They all vary slightly. Some children just grab on to the phonological approach. Other children really, really struggle. I've had children really struggle with Orton Gillingham, where I really needed to go deeper into their auditory processing so they could benefit from Orton Gillingham. I've had students who really had trouble with sight word recognition that really were very good decoders. I've had a lot of children who on the autism spectrum, for example, who we used to call hyperlexic. They could actually decode beautifully, but they couldn't comprehend what they had just decoded. So again, I'm not one who says, let's use these 3 approaches. I would say a well-designed neuroscience-based intervention combined with insightful teaching, where the teacher or the tutor actually looks at how, Doris Johnson used to call it diagnostic intervention, where you actually look at what the student's doing and how they're responding to your approaches and your kind of moving around in your approach with the child based on what they do well and where they're having problems.
Thank you so much, Dr. Burns. We are at our time limit, so if we didn't get to your question, you can email us at webinars@scilearn.com, and don't forget to complete the survey. And thanks for joining us today, and then be on the lookout for an email in the next couple of days to the recording. Thank you, Dr. Burns.
Thank you.